Hello and welcome to QED Stata 4 from part Q5. Now we're off to Iztapalapa and the rush hour in Mexico City. Well known as one of the worst of many very seriously congested developing country cities. And there was a recent piece of research there that a 1 hour journey, in other words 1 hour is when you just there's no traffic jams, actually takes 2.5 hours. So we want to test the accuracy of this claim. Here's a null alternative hypothesis. So Q5. Do these imply a one-sided or two-sided test? Why is that appropriate? Well, one-sided or two-sided means what kind of data would make us reject the null hypothesis? Now, here the claim is that it's 2.5 hours, and in this case, we want to know the accuracy of this claim is the key phrase up here. In other words, if we find that in our sample the mean duration is way over 2.5 hours, we're going to be able to say to these traffic researchers, no, that's an underestimate, it's way higher than that. On the other hand, also, if we find that we're breezing through easily in the sample and the mean of the sample is well under 2.5 hours, we will also criticize them and say, no, your figure is too high. So we're going to reject that 2.5 hours as being not accurate if we get a mean result that's way over that or way under that. In other words, we're looking for a two-sided test. So whatever result we find, we want to know what's the chance of being this far above or this far below the 2.5. So that affects the way we interpret, affects the p-value that we choose when we've done the test. So the rest of it's pretty standard stuff. So import the data, do the same test as previously. So stata, here we come. Import a Renimo, to use the technical phrase. There we go. Oh no, not Burkina, we want not Lusaka, we're in an order. Iztapalapa. Okay, that's good. Yes. So there's data. It's always a good idea to just check what else is going on. Just look at the descriptors just to make sure that as a kind of sense check rather than just doing a test and relying on that. If it was like 250 or something, so yeah, oh no, that's the number of observations is 273. Oh, mean is 2.55, so it's really close. So just looking at this, I'd expect I wouldn't reject it, but you never know because it's a big sample. But it seems that the mean of the sample is pretty close to what they claim, so maybe that is accurate. So we need to test that. Either it's accurate or it could be that there's some sampling error which is misleading us, which is what the t-test will try and indicate. Hours equals 2.5. That'll give me an error because I only got one equal sign. Okay, so there's results, test value 2.5, and now remembering this time we would reject this if we get either data above or below. So it's this middle one. So the alternative hypothesis is the mean is not 2.05. So we're going to reject in this case or in this case. So we found 2.55, which is only 0.05652 hours away from the actual hypothesized mean. But the calculation is telling us that, I think it's because we have a big sample, that if in fact the mean among all journeys taken is 2.5, the chance of selecting 273 random journeys and finding a mean as far away from 2.5 as that, either as far above or as far below, is 0.027, so it is less than 5%, so it's pretty surprising. So we would, in that case, because that's pretty surprising, reject this null hypothesis. Yeah. So descriptive statistics suggest it's quite close, but in fact, when you analyse it, the chance of getting as far away from that with a sample of that size is less than 5%, so we can reject the null hypothesis in favour of the alternative one. So there is fairly strong evidence here that the standard route is not 2.5 hours, so that's an inaccurate result. And the reason for that, I think, is that the sample size is so big, it's really unlikely that you can get that far away from the mean with that bigger sample. So size of sample, it gives you what's called more statistical power. So more chance of rejecting something if it's not correct, because even a small difference, you can say that definitely is a real difference rather than just random error, because with a big sample you don't get that much random error. Okay, so conclusion is that though it's not very good news that a 1 hour journey in Mexico City only takes you 2.5 hours. Okay, so on to Lusaka loads in the next example, but for now, thanks for watching.